What's going on, you guys? Mr. Allen here. We are about to graph a rational function here. F of x equals 1 over x minus 2 plus 3 on the outside. And we got loads of fun information to fill in as well. Not every test is going to ask you all this stuff. I'm going with a lot right now. A plethora of information, if you will. Alrighty, let's go for it. Domain first, dogs. Domain first. Domain is with my denominator there. X minus 2 is what I want to focus on. What x value will make that denominator 0, which causes me to divide by 0. I do not want to divide by 0. 2 minus 2 gives me 0. So x cannot equal 2 for my domain restriction. Domain restrictions can also be written like this. Some people like to write it where they use interval notation, negative infinity to 2, union 2 to positive infinity. I personally don't like that notation for rationals. Whatever your teacher wants you to do is cool, but I like the x does not equal 2. Some people want to do like x equals all real numbers except x cannot equal 2, and they use fancy brackets. I'm gonna keep it easy, right? This is street math right now, okay? I'm just gonna give you the nitty gritty. What you need to know is that x cannot equal positive 2. Cool, awesome. Now, since nothing's gonna cancel here, there's gonna be no holes, none. But the only thing I'm going to have here from my denominator there, from my domain restriction, that 2 there, that's going to become my vertical asymptote of x equals 2. It's a vertical line, and I can actually plot that right now. Vertical line, x cannot equal positive 2. So that vertical asymptote, that vertical dashed line tells me that graph is not going to exist there, okay? It can't exist there because I can't plug 2 in, right? It's going to exist nowhere on this graph. Cool, wonderful. All right, continuing. Range and horizontal asymptote go together, okay? So here, this fraction, that's going to get really, really close to 0 as I go farther to the right and farther to the left. If numbers get really, really big, I have 1 divided by some really big number that's really close to 0. If I divide by a really big negative number, that's still going to get really close to 0. But I shift this up 3, so my horizontal asymptote is now going from y equals 0 to y equals 3. So your original parent function, the 1 over x that you see down here, has a horizontal asymptote of y equals 0. If I shift to the left or right, that's not going to change anything. But if I shift it up or down, it does. All right, so this time we got y equals 3, and our range restriction will be y cannot equal 3. And you can write it in a similar way there, except for the 2's would then be 3's. All right, now the range does not always exclude that horizontal asymptote. There are some weird things you'll see in future rationals, but we're keeping it basic now, so we're good with that. All right, I like that. I like that. It's beautiful. I'm going to go ahead and actually plot that bad boy, right? Wonderful. Whee. Okay, cool. There's my horizontal asymptote. Man, we're packed with info, and we're not even done. All right, now let's graph this thing. Let's graph it. So in order to graph, I'm going to need some points, right? So what I like to do is I like to get a couple key points here, okay? Key points. So key points are on the, if I have like a hole or whatever it might be, but I think the easiest thing to do here is go left and right of my vertical asymptote. So what's 1 to the left? That'd be positive 1. Right here is positive 1. What's 1 to the right? That's going to be 3. So what I'm going to do here is I'm going to get some ordered pairs. And hopefully we can see this all right now. I'm going to have 1 being plugged in, and I want to get something out for 3. And I also want to get something for 3. So 2 ordered pairs. How do I get that? I can plug it in to my function. I would have 1 over 1 minus 2 plus 3. Well, what's 1 over 1 minus 2? That's 1 over negative 1 plus 3. And then I'm going to have negative 1 plus 3 is positive 2. So 2 would be my ordered pair. 1, 2, right there. Same deal with 3. I'm going to have 1 over 3 minus 2 plus 3. Now I'm going to have 1 over 1 because 3 minus 2 is 1. And now I've got 1 plus 3 is equal to 4. So 4 is my y coordinate. If I have an x value, I plug it in, I get a y value. Substitute, right? Some people like to use substitute, not plug in. Bougie math people, you know? All right, 3, 4. Boom, 3, 4. So now I know, based off of like my parent function, how things look, it's going to look something like this, right? And it's going to come up through here. And it looks something like that right there. Beautiful. We could find x and y intercepts. I'm not going to do that in this video. Usually, 1 point on either side of the vertical asymptote is enough. Most teachers will accept that. I know I would accept that. And if your teacher wants you to do something else, I would listen to them because they're the ones grading your test. All right, I can't go and talk to them for you. Sorry. All right. End behavior, asymptote behavior, transformations. I'm going to knock out transformations first. This is definitely a very general thing that we can ask you at either regular or honors level. I'd say these might be a little more honors level for some schools. So for transformations, all right, well, what's happening for my parent function 1 over x? On the inside, we got to think opposite, right? This is going to go to the right 2, and on the outside, it's up 3. So we can just say right 2, up 3. All right, cool. That's good there. Now here, little end behavior and asymptote behavior. If you've been talking about this in class, pay attention. If not, you could probably just move on, right? But make sure you hit like and subscribe and leave a dope comment. Be like, hey, bro, thanks. Okay. Anywho, end behavior. As x is approaching negative infinity, as we're going to the far side, what is my graph getting closer to? It's getting closer to positive 3. Woo! Then as x approaches positive infinity, as I go to the right side, where is it going? It's getting close to positive 3 once again. I like it. Now, asymptote behavior. We're talking about my vertical asymptote. We just talked about my horizontal asymptote. End behavior and horizontal asymptotes go together. Remember that. Vertical asymptote. Okay, so as x approaches that vertical asymptote, which is at 2, x equals 2, but it's doing different things on each side. So we have notation for that. From the left is a little negative up in that kind of exponent spot. And that's saying as I come from the left side, what's it doing? It's going down, dogs. It's yelling timber. F of x is going to negative infinity. Woo! And lastly, and I'm going to take a nap because this is a whole lot of math, man. We got 2 going from the right-hand side. So as I come towards my vertical asymptote from the right-hand side, whoop, we're shooting up. We are going to positive infinity. To infinity and beyond, rather. All right, there we go, man. That's awesome. Beautiful. Lovely. So top section here and that guy right here, definitely regular Algebra 2 caliber questions. This might be a little bit beyond there. And the 2-point rule. Most people are going to do that. I think that's the coolest way to do it. That's pretty dope. That's awesome. Hope you guys enjoyed. I enjoyed it. I will see you later. Deuces. See ya. Peace out. Bye.